Hello, everybody. I'm Tanner Valentine, the Director of IT here at AIS, and I welcome all of you to our second technical development workshop. Today, we're going to be looking at blockchain, this exciting new technology that I'm sure all of you have heard of by now because of the recent popularity of cryptocurrencies. More specifically, though, we're going to be looking at how to create a simple blockchain within Python, on top of learning the basics of blockchain. If any of you have any questions or concerns, or hardware issues, please come to my help desk hours this week. I'd be happy to set you on the right track and keep you involved in the workshop. That are the words. Without further ado, let's get into this. So before we get into the nitty-gritty, I just wanted to give you all a rundown on how this workshop is going to proceed. I wanted to start with explaining the importance of blockchain technology and why you should care about this presentation. From there, I'm going to explain how the blockchain database is different than other currently used technologies. This will cover database structure, trustful and trustless systems, and mining. And lastly, fully equipped with the foundational knowledge that we cover of blockchain, we will, as a group, write the code to create a simple blockchain that saves transactions between users. As we're about to begin, I first want to emphasize to you all how important it is to keep your eye on blockchain technology. Unlike Python from our last workshop, blockchain is still very new. We're only at the cusp of its capabilities. One of the key components to blockchain is its lack of a governing entity. In the context of a use case like Bitcoin, this could mean a future without banks, with peer-to-peer cash systems replacing them entirely. The strength and immutability of blockchains could accelerate the contract process worldwide and speed up global shipping processes overseas, by air, by truck. These possibilities don't even mention the personal benefits of working with blockchain. With its use only going to be on the rise, having knowledge of this technology on your resume could give you a leg up in future competition and in any interviews or any job you're looking for, really. As I've mentioned before, the blockchain is a type of database. So let's refresh ourselves on some basic concepts about databases to see how it's different. One of the main impacts of a database type is the type of data it stores. SQL databases and those like them hold structured data, which is a predefined model and format. All the data that goes in there has to fit that format because of the way. One of the main impacts of the database type is the type of data it stores. SQL databases and those like them hold structured data, which has a predefined model and format. This formatting allows for smaller databases and a lot more scalability because they have format down. On the other side, NoSQL databases, which is just one of the types, and others hold unstructured data, which includes things like images, media comments, social media posts, product reviews, things on Yelp, anything like that that does not have a predefined format. These data sets are obviously much larger, so it's harder to work with them on enormous scales. But what's between these two types of databases that is, concurrent is that they're centralized. There is a single entity housing all of them and managing all of them. In a centralized database, one administrative entity has access to all the data. They can alter data. They have the power to give permissions and access to other users. This is what we call a trustful system. The users of the database must trust that the administrators will not abuse their position and give out unearned permissions to people who shouldn't have them. This system has worked for many corporations, but what happens when someone who shouldn't gets permissions? What happens when a disgruntled admin gets fired? The human aspect of these systems is what put people's data in danger. As we move forward, I'll try to show you guys the way blockchain attempts to solve these issues, even though it has its own set of problems that come with it. To address the issues with databases at the time, Satoshi Nakamoto published a paper in 2008 about a peer-to-peer electronic cash system. They went on to launch Bitcoin in 2009 as an open source software, allowing anyone to inspect, modify, enhance it, basically use it. The start of Bitcoin, however, is not that simple because Satoshi Nakamoto is not a person. No one actually knows who's behind the creation of this technology because it's just not a real name. It's not a real person. It's registered to no one. One of the prevailing theories, however, is that it was a team of people who created as a response to the 2008 financial crisis. Probably maybe they were upset with the bank or something, but that's all legend, not confirmed. The goal, however, was to create a decentralized database, which meant user records need to be encrypted to protect from other malicious users. The goal was to create a decentralized database, which meant user records need to be encrypted to protect from other malicious users. Let's delve a little further into what the decentralized database is. Blockchain, also known as the decentralized or distributed database, is exactly what it sounds like. Rather than a single entity storing, accessing, and managing the data of an entire database, the information is spread amongst all users involved. Whenever someone joins a blockchain, a compressed version of the entire database is installed on that node. When I say node, I mean that could be a laptop, a desktop, a phone, anything that can access the blockchain. There is no overarching entity that manages this database. Through the actions of all the users, all the transactions are stored, saved, and proven correct without the help of any admins. No need to give anybody permissions. Whenever a transaction does occur, all users of the database are consulted to make sure a fraudulent block is not being added to the chain. This is what we call consensus checking, in which every node is used to determine what is and what is not correct. No administrator also means that there's no person giving out database permissions. Everyone only has access to their personal data by design, not by given permissions. This takes out the concern of another person's goals putting your data at risk. This is why blockchain is called a trustless system, or sometimes called the trust protocol. Not because we cannot trust it, but because we do not have to trust others with their data. We do not have to have that trust with the admins that are actually running it. This decentralization is what threatens financial corporations like banks in the future. If a customer can get a loan from someone else and keep their money safe without the bank, why does the bank need to stand? It's a gross oversimplification, but you understand what I'm trying to say. Having a decentralized system is inherently dangerous to systems that are built on centralization. All of this talk of no banks might have you worried a little bit about security, and I don't blame you. Thankfully, the crypto in cryptocurrency, which is intertwined with blockchain, stands for cryptography. The cryptography for blockchain extends past just cryptocurrency, however. The blockchain works on a system of public and private keys where everyone can see the public key, but only each user can see their own private key that connects to it. You can think of the relationship between the two as a mailbox for transactions. The public key is like the address to the mailbox. Anyone can see it, they can send data to that box. The private key is like the mail key you get in an apartment. You can use the private key to access the data sent to the public key by other users or yourself. Users must keep track of their private keys. Thankfully, with cryptocurrencies, these are stored in an e-wallet of whatever node you're accessing the chain on. The blockchain is not only protected by encryption, with its innate design allowing for a stronger system overall. Like I mentioned earlier, the distributed database works off consensus checking. Since every user of the database has a copy of the entire chain, whenever someone tries to create a new block, the entire user base gets checked. To check this, we go through each block, which is essentially one transaction, to check if the hashes are correct. I'll explain what hashes are soon, but remember them now as the identifier of each block, like its name or its ID. Each block in the chain holds its own hash within it and the one of the previous block. So each user's node would check its resident chain to compare hashes with all other users. Whenever someone tries to add a block, every single person's node would go through the chain, check through, like, hey, the chain they have is correct. It has the correct previous hash all the way down the line. If someone in the consensus shows that the chain is fraudulent, that block in the end is not added. This is a little bit more in the proof of work system. People will use computers to solve incredibly difficult math problems for each block, slowing down the process as well as making it cost significant computational and electrical power. This sounds like an issue, but in the case of Bitcoin, this is how it gets its value. By costing resources and remaining scarce, it adds value to the blockchain itself rather than just the popularity of it amongst other users. On top of all of this, I want you guys to look at the top of the slide and look at the key term immutable. The blockchain is so secure because no block on it can be altered or deleted after it's made. If it's altered, then it will have a new hash. So it would not be checked in the consensus, and it cannot be altered at all. So, that does mean in the future, if you possibly send some money to the blockchain that you didn't mean to, you might not get it back. But it also means that all your records will stay safe exactly how they were at the time you made them. Now that I've mentioned proof of work, let's dive into what hashes and hash functions are. A hash function is a math equation that will take data of any size and convert it into a fixed length string of numbers and letters. It can be anything, any type of data. It all gets just put into a single type of string of data. This function is not reversible. So if someone gets the hash for some of your data or the hash for a block, they cannot, put it in reverse and find out what it was before. This can hide your data, but it also makes the database incredibly small, which is why every user can have a copy. In the blockchain, these hash signatures are used as identifiers, like I said before. Each block contains the hash of itself and the previous block's hash. The hashing algorithm within blockchain is SHA-256, which stands for Secure Hashing Algorithm, that makes 256 hashes. It's just a minor detail, but that means that every hash signature is going to be a 64-character string. Now that we know what the algorithm does, we can revisit how the concept of proof of work actually works. Building off the hash algorithm as designers, we can set our block to have a target of a hash. For example, you could want the first 5 characters of every hash signature to be the number 0. To make our hashing algorithms do this, we need to add nonces into the equation. Nonces are numbers that are used exclusively once for some type of work purpose. If we add a nonce to the hashing algorithm, it would change the output of the hash. But what mining is essentially finding new nonces and retrying those equations over and over and over and over until we find the nonce that goes into the equation that makes the hash with the first 5 characters being zeros. That's what you do. That's the whole process of getting to a targeted hash. These are the complex math problems we discussed before that makes proof of work work. For Bitcoin, miners use their computers to solve the targeted hash problems of every new block being added. Since nonces can only be used once, a new one has to be used for each block, requiring miners to use more computing and more electric power for every new block that's added, which makes the value of Bitcoin rise and rise and rise. These miners, you may ask why they'd want to do this and spend all these resources, actually find the correct hash with their machines rewards them with Bitcoin in return. So it actually, the system is a little circulatory. It incentivizes them to keep going, to keep the system running itself. The electricity costs are not only a downside though, because they have another safety utility for the blockchain's users. Creating any new block, inherently costs a certain amount of power now. And that means that any hacker that wants to fraudulently add blocks or add many blocks would have to also mimic the energy usage and computational usage that that block would have cost normally, which means that they have to mimic that. They have to mimic the correct blocks, the correct hashes, which makes this process incredibly hard to hack, which makes our data that much more safer. Congratulations, you guys made it past our little lecture part on the basics of blockchain. I hope you survived. I hope you were not too confused. We're not trying to go super deep into this. Now everyone should be able to open their template Python file so we can get some real hands-on practice. Like I said before, if anyone has any questions and was not comfortable with any of this so far, please feel free to email me or drop into the help desk hours for assistance. I don't want you guys to just, get stuck on something and quit and be like, this is too hard, or I don't understand this, or I feel like I should be taking notes, like I should know much more. Please don't get concerned. Please just stick with me. I want you guys to get through this. I want you guys to enjoy this, really. I want you guys to get something out of it. So please, if you need help, anything, let me know. Without further ado, let's get into the deliverable. See you guys then. Hey guys, this is Tyler from the future, here to get you started on the deliverable for our second TD workshop. Today we're going to demonstrate what we know by creating a very small, very simplified version of the blockchain. Blockchain is meant to simulate, a very simple version of cryptocurrency like Bitcoin. Just like our last workshop, I've supplied you guys with a template deliverable, so you can just kind of fill in the code. A lot of it's still there. I'll guide you through it, and there are still a bunch of comments that are out to try to clarify things, maybe something that you didn't understand, maybe you don't know the purpose of. Now to begin, like you've seen in our last workshop, which we already have the top here, we need to import our proper libraries. So within our deliverable, we need hashlib to be able to create our actual blockchain, hash these nonces and create hash signatures. We need the JSON program to actually, make our chain be able to be printable in a JSON format and easily readable by the viewer. And we need the time modules. So we can actually get timestamps of each of the blocks, each of the transactions. We can know when they happen. Our first step is to define the blockchain class itself. You can see the class up here. We need to actually define our individual chain. Then right here, we will define our list of pending transactions. So when someone creates new transactions, they get put there, and then when a new block is added, they take from pending transactions and are put into the chain. Then lastly, we need the method to create new blocks right here. I already have it listed out. And fun fact, this is actually the original hash of the Genesis block of Bitcoin. It's the very first hash signature for a blockchain. So a little bit of history right there. So I'll start by initiating the chain right here. Then get twice self.chain equals empty because there's nothing in it right now, obviously. Then we'll do self.pending transactions, also empty. And like I said, this is already here for you. I wanted to keep this history here, so I was gonna have you guys write the whole thing. Our second step is to create the function that actually creates new blocks. You can see we have it defined right here with some parameters already, but we don't have anything within this block structure. We don't have the actual, the settings and the information each block needs in there. So what we're gonna need for our work is index, timestamp, your transactions, your proof, which is in our deliverable, it's the nonce that we use for our hashing. And then we need the previous block's hash. So let me put that one for you. You guys can just follow along. Index. You can find out what the index is of this next block by just taking the length of the chain overall and just adding one to it, because we're just adding a new block on top. Now, for the timestamp, we'll use the time module that we imported to get the exact moment of the creation of the new block. Transactions. We'll refer to the pending transactions list that we made earlier that we defined. And that will take all the new transactions that we've been putting in there and take those, put them in this newest block. Proof, and that's one of the parameters. So we can just write proof. And then the previous hash. That will be the previous hash. We have either parameters, or it can be hash of the chain block prior. All right. Now you can see at the bottom of this function that the transactions, the pending transactions, they get cleared out. So once the new block is created, takes all those new transactions from pending transactions, they're added to the block, put onto the chain. We realize like, hey, we don't need those new pending transactions. We already put them on here, already been used. So we clear out that entire thing. Then we append the block to the chain. Our third step will be to create two functions. One that gets the last block of the chain that from the one that we're at currently, and our second one to create new transactions. I'm not going to have you guys write a bunch for getting the last block because we've already written this before the self.chain. This is the entire function. I don't need to tell you guys more. But for the new transactions, look at the parameters. They're not all referenced within here. And that's because our transaction, the data that we're passing, has not been created yet. And now we think of the three things that we need most when creating these transactions. We need the sender, person who's sending money, the recipient of that money, and the amount of money that's being sent. So you can add that right here. Sender. And we already have these things, the parameters above, so we don't have to, write a bunch of code for it. We can just reference the parameters right here. Recipient. And lastly, amount. Now, this new transaction function puts this information into the pending transactions that we'd seen before in the new block function. This will put these in here and wait for whenever the next new block is formed, so you can take all the ones that are in there and put them in the blockchain. So one thing we learned back in the presentation is that these blocks use hash signatures as identifiers. So obviously we need to be able to create a hash function. So we have the template one right here. And basically what the entire thing is supposed to do is take all the data from the news block, get its key value pairs, turn it into a string. That string is fed to the hash function, which creates our hash. That's used for our identifier and used in the previous hash parts of the future blocks. So we need to put this in here. We already have the string object that takes all the key value pairs here. Now we have to create our block string, which puts all of that into a format that we can hash. Now we have two different versions of hash here. I'm going to start with the original hash and reference the hashlib library that we did at the start of this program. And then, so this creates the raw hash with the SHA-256 that we mentioned that creates a 64 character string that we mentioned in the presentation. So this puts that into the raw hash. And now we want to clean it up, put it in a way that we can easily read. It's a little more refined. So we're going to do hex hash equals raw hash dot hex digest. And with that, this will return that and we'll get our hash function or our hash signature, I should say. And those will be used within each of our new blocks that we're creating. Now, our final step is to just create the blockchain. You may have thought that we have done that before, but if you noticed, and we're here for our last workshop, these are all just define tags. We're just defining all these functions. So we initiated the ability for us to use this blockchain earlier, but now we actually have to call it. So that's incredibly easy. I'm just going to name our blockchain. And from there, so here to define the class, just have to put that one line of code, as are set. But I want you guys to be able to actually, see this in action, see what you're doing. So it's not just you writing some code and then calling it a day. So I've created some dummy transactions, 3 per block, with just random names. We have Satoshi for the founder, and just some random information so we can see this all in action. What we still are missing though is if you look back to our new block function, you have to put the proof in here, which is the nonce that we plan to use. Unlike mining where we have a target hash, we're just using any hash. So we don't really have to care about a specific nonce, just try not to use the same one that you've used before, obviously. So I'm just going to put in a random set of numbers, 2, 3, 4, 5, for this first set transaction, which we put in the block. And for this second block of these transactions, I'll just continue the numbers 6, 7, 8, 9. Obviously, you guys can change this if you want, but I'm just going to keep it as is because it's easier for me. And after all that, these will create our new blocks add them to the chain, and then we just have to print it out so we can read it. Now you can see it says Genesis block here because each blockchain needs to start with a single block, and that is the one that we created here with this information, proof of 100. So it's going to start with the Genesis block, then it's going to list the entire blockchain, but when it lists the blockchain, the first thing that's going to show up is that Genesis block. So we have that identifier for it. Now, this is the template, and I will distribute this to you guys, so I'm not going to save this. I'm just going to drag over my version. You see it's filled out the exact same way. And then if I just click function F5 or whatever your text editor is to run, you can see such a Genesis block, and then this going all the way down. So this is the start of the list, obviously it goes to here. This first block goes all the way down to here. You can see the index is 1 because it's the Genesis block. The timestamp, there are no transactions because we didn't put any there. Proof of 100, like I showed you guys. And then the previous hash is this one that we used in Bitcoin. But we can look forward to these other ones. Like this is the second block. Index 2 is timestamp, but in this one we have the transactions. These are the ones that we set up earlier. You can see it says sender recipient amount, and all this information is kept. And here is the third block. You guys can add as many as you want, but keep in mind these blockchains only keep track of transactions. They do not show you any balances for what people own or how much currency they have. That job is left to things like Coinbase or other programs that are wallets that people use for cryptocurrency. Those programs read through the entire chain to find everybody's balance values at a given time. This, we're not going to code all that. So I just want to show you guys how to actually create the chain. It holds up the transactions, all the information you need to refer to the last block. Like I said before, this is a really, really simplified version of the blockchain. I didn't want to have to go through the nonsense of getting targeted hashes and mining, and we want to have. This is obviously only a client side thing. You're not uploading this to, a whole user base that all the nodes are consensus checking. This is just to show the actual architecture of what a blockchain could look like. Obviously, very simple. I don't want to overload you guys because it's supposed to be fun and interesting. Now, assuming everything went off without a hitch, you guys have completed your second technical development workshop. I really hope you got something good out of this. Maybe some new passing interest. Maybe you're like, whoa, I love blockchain. This is my new career path. More power to you. That sounds really cool. Regardless, thank you all for coming and joining me. I really appreciate it. I put a lot of work into these. That being said, if anybody has any issues with this deliverable or with the program before or the presentation, any information that confuses you, please, 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 please come to my office hours, come to help desk hours, email me. My name's Tanner. I've already said that, but if you forgot somehow, please contact me. I would love to help. I don't want this to be, this is too hard. I'm going to close the laptop and just not complete the track because it's not that hard. I'm trying to make it not that hard for you guys, but that's my spiel. Thank you all for coming. I really appreciate it. And I hope you come back to our third workshop that should be coming next month. Right. You guys all have a wonderful day. Take care.